Yeah, hello. Yeah, so we are going to look at data visualization using ggplot2 package, which is part of Tidyverse collection. Okay. Yeah, so what we are going to do is let's open our R. And again, I have made the code available, which is this lecture 7 code, which I've actually made it available for you to be able to copy and then paste and follow along. Yeah, so we just lecture 7. Yeah, so you can copy the invariant part of the code. So you can copy right from the beginning all the way down to the univariate part of the code, and then you can actually learn along. Okay. All right. So first of all, what we are going to do is we are going to be able to load our data set, which is always the first thing, of course, you have to do. So we are going to make use of the HINS data, which is the National Information, the Health Information National Trend Survey data. So this first line of the code, of course, is actually going to help us get to our folder where our data is located, and then upload the data set. So let's run this line of the code. We put the cursor there, you run it, and there will be a dialog box which opens. So once this opens, you can actually look for whatever the data is found on your system. But this is the data you are going to use, the HINS data. So now the data have now been uploaded. So we can look at the heads of the data set. And then also, so always what I will actually recommend is, usually it's better for you to attach the data set so that you wouldn't have to use the $ to call a particular variable anytime you need that variable from the data, okay? So we can attach the data. Now, once you have attached the data set, whenever you are done with your analysis, you can always use the detach to untouch the data set. Okay, so let's run the summary statistic. So again, by running the summary statistic, it gives you a fair idea of the statistical summary of the data set and whether or not the data may contain some missing information which has to be taken care of before you perform any further analysis. So of course, we are seeing some information that are negative within the data set, which of course, then -9 or negative variables within the data set are coded as missing information, or in some cases even non-responses or refused to respond, which has to be taken care of or removed from our data set. So in this case, we are going to use this line of the code to be able to, so we are going to create a new data from the old data, which we are going to call it the HINS_new. So we are going to go into the original data set, and then within the original data set, we are going to use this line of the code to actually ensure that the variables we are going to use for our analysis are clean from negatives, okay? So for each of those variables, we are going to be able to select values for those variables that are greater than 0. For instance, for quality of care, which is a categorical variable, health insurance, a categorical variable, and then age. So, and also you have to be make sure based on how your data have been coded. So it's always important to make sure you are matching it with your code book to ensure that you are not removing information which is supposed to be in the data. For instance, there are instances in which people use 0 to represent a value within a categorical variable, right? Or a level of a categorical variable. So by excluding 0 means you are excluding a level of a particular variable, right? So you have to make sure you are doing the right thing. By for this data set, once those in which zeros are excluded means they are not part of the data, or they are not supposed to be part of the data. So of course, so, and then we use this sign is actually going to be able to allow you to include more variables for the cleaning process, okay? So health insurance greater than 0, and we go to age greater than 0, and then, and so on and so forth. And then, so we use the concatenate function, we group all the variables we are going to clean in a parenthesis, and then we bring the comma sign within the square bracket, okay? Make sure to do that to ensure that now you are actually doing that, and you need all the columns of the data set. So you are cleaning the rows of this particular variable by excluding the missing data, but at the same time, you wanted it to retain every single column of the data set. Okay, so we can go ahead and then run this part of the code just by putting the cursor. So now it has been run. So we can look at the head of the data set, which is still the same as the initial head of the data. And then also we want to attach the new data in which we have created, which is the hence data underscore new. So we run it, and then we can also run a statistical analysis to make sure that we are able to get rid of those missing information from the data set, okay? So here is it. So we're able, for instance, the quality of care, health insurance, age, gender, those variables that were selected, indeed, we have been able to actually eliminate the negatives from those data set, okay, those variables. So now we can proceed to start with our univariate visualization, okay, using the ggplot package. So first of all, before you proceed with it, you have to first of all install the ggplot package, which you can install tidyverse, and then thereafter you go ahead and then you can activate the ggplot2. So I already have tidyverse installed, so I will just go ahead and then activate the ggplot2. Once I have done that, now I can go ahead and use what is called the ggplot function to be able to plot any kind of plot I'm actually looking for. So now, first of all, what we would want to plot is we would want to plot a histogram of BMI, okay? BMI is one of those variables we have here. So we are going to plot the histogram of BMI. So first of all, use the ggplot, and then within the ggplot, you bring the data set. So this is the data, which is the hint data underscore new. And then now we have this one, which is the static, which is the AES, which allow you to select the variable in which you actually want to use for your analysis. So the variable in which you are going to select is the BMI. Okay, so we just want to plot the histogram of BMI. So we say X equal BMI. Now we can go ahead and then the next, so plus. Now we can continue with the code by putting in the code, we can continue here, but we just want to ensure that we have a clean code. So you enter to initiate the next line, okay, where we are going to introduce the function to be able to plot the histogram. So we are using what is called the geo underscore histogram, okay, with the bandwidth of equals to 2, and then with the fill, which is going to be a color which is going to be fill each of the bars, which we are using the steel blue, and then the color we are going to use black, which is going to be, the edges, okay? And then we are going to use the ggtitle function to be able to put in the title of our plot, which we are naming it histogram of BMI. You can name it distribution of BMI. Always make sure you use appropriate name for your names for your figures to make it more readable. And then also you have X lab, which is we are going to label our X axis as what? BMI level, okay? And then we are going to label our Y label as what? Count, okay? Yeah, so in other words, it could be the frequency. So now, and then again, for each of them, now, after this line gives us the histogram, okay, and this line plus this line allows us to give the title of the histogram, okay? Then plus this line allows us to be able to give the X label of the histogram, okay? And then plus this allows us to give the Y label of the histogram, okay? So let's run it. We can highlight on all of them and run it, or you can just put the cursor there and then just run. Okay, so now there's our histogram, which is looking clean. So we have histogram for BMI. We did the count, and there's the what? There's the levels of BMI. So, I mean, you can see that it's kind of fairly normal, but we have some kind of skewness within the data, which is very skewed to the right. Okay. So in most cases, this gives you an idea of if you want to perform a further analysis now, you would want to look a little bit into the BMI to ensure that it doesn't affect any of the analysis you'll be performing subsequently. Okay, so next we want to generate Boxplot. Okay, so to generate Boxplot, what we are actually going to do is, again, using the same thing, the ggplot, we are going to call our data set, which is the clean data, the hence data underscore new. And then again, we are using the AES, the static, to be able to have, we are going to have BMI on the y-axis. So we have, we want it to be vertical, right? So we are going to have y-axis to be equal to the BMI. And then now we are going to use this function. So plus, we are going to use this function, which is called the geom boxplot, to be able to create the box plot. And then we are going to fill it with what? Pink, okay? Then plus, we are going to also create a discrete scale, okay, of our box plot. And then thereafter, we are going to be able to give it labels. So we can use the labs equal, we have the title to be equals to the box plot of BMI, and then the y-axis, which we are going to give it the levels of the what? Of the BMI. Okay, so unlike above here, over here we just use the labs function, and then within the lab function we are able to create our title and then also our Y label. Okay, and we could have actually go for this form, but in this case we are going for this, which is still going to give us a very pretty plot. So there's what we have. So we have the y-axis here, and then we have our box plot, which is the title we actually give. And then remember the y-axis, we gave it as what? The BMI level. And then you can see that clearly there's a lot of these values you see here after the maximum level of the data is more of what outliers within the data set, which has to be looked at. And we have another one outlier here. But you can see that, I mean, the first quarter, the third quartile, the first quartile, and then the medium, I mean, it's kind of fairly normal distributed distribution for the BMI. Okay, so now we also want to generate what is called the dot plot, which is also another visualization which you can generate, which is a continuous visualization you might want to generate. Okay, so to generate a dot plot, we are going to actually use a different data which is not big enough, right? I mean, we can generate a dot plot using the hint data, but however, because the hint data we have over 1,000 observations, using it for a dot plot can look very messy. So we are going to use what is called the MT-cars data, which is an inbuilt data in R. Okay, you can actually look at the head of the data set, and possibly you can even look at the dimension of the data. Okay, MT-car. Okay, We can even check the dimension of the data to look at. So it has 32 rows and then 11 columns. So now we can go ahead and then create our dot plot, okay? So again, it all starts with the ggplot, and then empty cast, which is the data set. And then we have the AES, the AES of the variable in which we would want to plot. We want to plot the dot plot distribution for miles per gallon for the empty cast data. Okay, so we are using x equals to that particular variable we would want to generate a box plot. And then now we have geom.plot, okay? Geom.plot, and then we can have a field. So within the we could have just have geom.plot without anything within it, and we will still be able to generate a dot plot. But we would want to make it quite aesthetic, right? Look quite nice. So instead, we would actually want to add some more information, right? And so the information we are actually adding is we want the field to be gold, and then we want the edges to be what? Black, okay? Yeah, so for instance, assuming we decide to clear this part of the code cut, okay? And then now let us just generate the box plot. There's how it looks like. Sorry, the dot plot. So there's how it looks like, right? So not putting anything within the geo.plot, you are so, as long as you have the variable in there, you are still going to be able to generate your dot plot. But then you want to add some additional beauty, right? And that is why we actually put in some information within the geom.plot. So we have the field, and then we have the labs. Again, we have the title, we have the y-axis, which is representing the proportion, and then we have the x-axis, which is representing the miles per gallon, okay? So now let's run it. Okay, so here's what we have. So the same thing, but the only thing is here, this time we have a more colorful kind of a plot, which is a beauty you might just want to, sometimes consider, okay? It's the same thing for here. The geom box plot, we could have just taken away the field and just have geom box plot parentheses of the BMI, and we would have still have a pretty nice box plot. But then again, for beauty's sake, you might just want to apply some additional argument to make your plot look very nice. Okay, so there's our dot plot. So basically the dot plot allows you to be able to actually access, perhaps maybe if you want to know which MP gene have the highest frequency, or in terms of maybe proportion, right? So for instance, over here, the miles per gallon, perhaps maybe the highest is, we have it to be about, 21 miles per gallon, or maybe 22 miles per gallon, which is having the highest frequency or the highest proportion, right? So that basically what the dot plots actually allow you to be able to know, to be able to understand which value has the highest frequency within your variable, right? So now we can also plot what is called the bar plot, okay? So with the bar plot, we can actually, again, you start with the ggplot, then you come with your data, you put in your data, which is our hints data underscore new. Then there's the static, which variable are you looking to plot. Now remember, in terms of a bar plot, which is a bar plot, we only use a bar plot if we actually want to plot a categorical variable, right? Or a nominal variable. So in this case, you have to be able to let R understand that, the variable you are coming to plot is a categorical variable. Hence, we use x equal factor into brackets. So factor allow our to understand that, oh, this variable is a categorical variable, right? So it's the factor of smoke star, okay? So within the aesthetic, we said that X equals factor of the smoke star, which we are coming to perform the distribution of smoking status of individual within the data set, okay? And then plus, we have the geom bar. So for bar chart, we use what is called the geom bar. And then again, just for beauty, we put in some fill, which we are using what is called the tomato, and then we have the color, which is the edges, which is what black. Again, we have the geom title. We have the geom title, the GG title, which gives us the title of our plot, which we are naming it bar plot of what smoking status. The X lab, which is allow us to be able to have what the X label, and then the Y label is what. So our X label is smoking status, our Y label is what? Frequency. Again, in each of the cases, you bring plus, okay? So let's run this line of the code. Okay, so now we have our box plot, which is giving it the different smoking status. So we have 3 smoking status, or smoking status have 3 levels, okay? But I mean, for even a much better plot, you have to be able to ensure that instead of 1, 2, 3, you have proper names for the 1, 2, 3. I know 1 is representing current smokers, 2 is representing former smokers, and 3 represent never smokers. But that's something you have to do. So talking about that, now we are going to generate a more advanced bar plot, okay? Just to make it look more nicer. And we are going to use the quality of care variable, which is also a categorical variable with 5 levels, okay? So the individuals were asked about their quality of care in which they were rating from excellent to poor, okay? So within, the data, within the data we have, so for instance, we can say summary of, let's say, our factor of quality care. So if you run this, you can see we have 1, 2, 3, 4, 5. In each of them, we have the counts or the frequency. But 1, 2, 3, 4, 5 it's not very meaningful, right? So we want to make it more meaningful. So now we are going to create a new variable within our Heinz data underscore new. And that new variable, we are going to name that new variable as quality of care new, okay? That's quality of care underscore new. So now we are using this $sign to indicate that we are creating a new variable within our Heinz data underscore new, okay? And then now we are going to go into the data, okay? And then we are going to call the original variable of the quality of care. So what we are saying is that, okay, if you go, so you bring the square bracket and you say, if you go into the Heinz data, select the quality of care, and with double equal sign, which means strictly equal, when it's, so for quality of care equal 1, assign it to excellent. Then in the same way, creating a new variable, which is the same variable, which is the Heinz quality of care new, go into the Heinz data, and for the quality of care equal true, assign it what? Very good, okay? So now we do it for the same, we do it for the other values of the quality of care, which we have good, fair, and then what? Poor. And so now we can go ahead and select all this code and run it, or we can run it line by line, okay? So now let us look at the head of this data. So now if you look at the head of this data, now we have a new variable added. So there is the original variable. The original variable is quality of care, which is this variable. But now we have a new variable which has been included, which is called what? Quality of care underscore new, okay? And then now we can actually go ahead and decide to find the summary of the quality of care underscore new to see what's different. So quality of care underscore. So new. The quality of care underscore new. Okay. So let's see. Okay. So what we are going to do is now, in order, so again, we can go ahead and then be able to attach this quality of care. Okay. So attach. So attach the HINS data. Okay. Okay. So now we are attaching the HINS data to ensure that now it's able to recognize the quality of care underscore new. Okay. So now we have attached the HINS data. Now, if we find a summary of the quality of care underscore new, we are able to get it. Okay. So at this point, at the time before I attached the data, I couldn't recognize the quality of care underscore new because it wasn't part of the initially attached data set. But now we created a new variable within the HINS data underscore new. We have to reattach it to ensure that it recognizes the new variable that have been added. Okay. Okay, all right. So now we have that variable added. So what we can also do next is also we are going to be able to create what is called we are going to create this bar plot, which is going to give us the percentages of each of the plot. Okay, all right. So first of all, we are going to use dplyr and then the scale, which for each of these packages, if you have it installed, first of all, you have to install it using the install.packages, okay, before you can load it. I already have them installed, so I can go ahead and load it. So now I can go ahead, I'm creating a new data, okay, in which I'm going to be able to let the data have some frequencies, including their percentages, so that I'll be able to use it to properly draw a bar plot, okay, in a different way. So now, so this is the dplyr where the dplyr is taking the effect. So with my new data, go into the HINS data, again using this 2 sign, which is the percentage greater than and the percentage. Now you create a count of the quality of care, okay? And then also you use what is called the mutate. We are going to be able to calculate some percentages, which we are using, and which is the number of rows or the number of observation being divided by the sum of the observation. Now, for each of the levels, we are actually going to be able to divide the number of observation by the total sum within our data set. And that is we creating the relative frequency, okay? And then also we are going to use this one within the mutate function. We are going to use assign there's a variable in which we are actually creating, which is PCT labeled, which we are going to be able to use it in calculating the percentages and then also including the percentage sign. Okay, so let's run this line of the code. Again, you can just put the cursor and then run the line of the code. And then let's run it. So now you can see we have the quality of care. We have the number of observation, which is the N. We have the PCT, which was the proportion, which was actually created, which in other words, relative frequency. And now we have it in percentages where we actually multiply each of them by percentages and then run it up, okay, to the nearest whole number and adding the percentage. So now what we are going to do is we are going to plot a bar chart using in a descending order, okay? So within a ggplot, we're actually going to use our new created data, which is the plot data we created, okay, for the quality of care. within the hints data underscore new. So now there's the plot data and our aesthetic, which is AES. We are looking at order the variable in descending order. Okay, so the variable, which is the quality of care variable, which is this variable, we are going to reorder it in descending order. And that is why we are actually taking the minus PCT. So this is our PCT variable. And so we are actually saying give it to us in a decreasing descending order, which is from highest to lowest, right? Yeah. And then also we have our y-axis to represent the PCT, which is the proportion or the relative frequency, okay, of each of the levels of quality of care. And then now we are going to use the geobar to actually create our bar chart. And then within it, we are going to have what is called state to represent the identity. And then we have fill, which is the fill we actually want. And then there's what? There's the color, which is the edges of the bar chart. And then geotext. So geotext is actually allowing us to be able to add the PCT label in which we actually created, okay? So to be able to add that on the bar chart. So within the geotext, we say that the EST function, the label should be equal to what the PCT label which we created and adjust it to what VGES, which is adjusting it in what negative 0.25. Okay, that's where the position of the percentages you actually want. And then also we have the y underscore scale underscore y underscore continuous, which is also a function which you are actually going to be able to use what the percentage. So in this case, we say that labels is equals to the what percentage, then plus we now have the labs where we said the x-axis should represent the quality of care, y-axis should represent the percentages, and then we have the title, which is the participants by quality of care, okay? And then we want to flip it for it to look horizontal instead of vertical like we have for the smoking status here, okay? So now let us run all this line of the code. Okay, so there's what you have. So now there's even a more advanced way in which you are able to give the percentage for each of the bars and flip it in a very horizontal way. And then now you have it look very nicely. Okay, so now we can also draw a pie chart, okay? So regarding a pie chart, again, we are going to be able to draw a pie chart using our quality of care new, okay? But then before then, we know, if we run this line of the code where we have a summary of the new variable we created, which is the quality of care underscore new, okay? Quality care underscore new. Now there's what we have, okay? So let us try to create our own data frame from this, okay? Where within the data frame, you know, we have data.frame, and then we are going to have the group. We are going to give name group equal, which is going to be the names of the levels, which is excellent, very good, good, and then fair, poor. And then for each of them, excellent is representing 863, very good, good, and then fair and poor. So we actually create a vector, which we are going to name it as what counts within the data frame, okay? So this gives us the numbers of the number of count for each of the groups or the levels of the quality of care data, okay? All right, so let's run it. Now we can print out the data. Now we are able to see. So we have the group and then we have the count, okay? Now we can proceed and then use this quality of care data to generate our pie chart, okay? So again, we are going to use the ggplot, which is the function, the plot function we need. And our data we are going to use is the quality of care, okay? And then now, for our aesthetic, which is the AES, we are going to have X, you leave it empty, but the Y is going to be the count, okay? And then the fill, you are going to fill it with the group, which is this group. So Y is representing this count, each of the count, and then the fill is representing the group. And then we are going to use the geobar, although the geobar usually is for bar chart. Down for pie chart, we are also going to use geobar within the ggplot. Okay, and then we are going to have weight equal 1. We are going to have the start equal identity, and then we are going to have coordinates underscore polar, and that is where we are actually able to generate the pie chart from. So we have in inverted commas, we have Y, then comma, we have start equals 0, okay? This one is very important to be able to help you generate the pie chart. And then now we have the GG title, which is the title we want to give to our pie chart, which is pie chart of what quality of care. So let's highlight and then run everything. So now here's what we have. So you are able to now create your pie chart with each of the for each of the quality, the levels of the quality of care. Okay. Okay, so now next we can also have an alternate different kind of pie chart, okay? And that's what we have, what is called the tree map. So the tree map is very similar to pie chart, but it gives you a different view of the pie chart. So before you use it, you have to be able to install the tree map, the tree Mapify, okay, which is a package that has to be installed, and then you now load that package, and then also you have to load your dplyr package, okay? Now, once I think I've already loaded the dplyr package, once you've done that, now we are going to create this tree map for the quality of care. So we are going to create the a data from the quality of care, which we have it to be plot data, okay, from our the HINS clean data, which is the HINS data underscore new. Again, with this sign, which is actually going to be able to select the variable you actually need from the HINS data. And then we need the count of the quality of care new, okay? So this is the data, so let's run that data. Okay, so now we have run the data, we can choose to run it and then see. So we are able to get, now this gives us the levels of the quality of care and then the number of observation for the quality of care, okay? So now we are ready to create that tree map. So again, using the ggplot, we have our plot data, which is this data we created here from the quality of care. And then we have the aesthetic, which is within the aesthetic, we said that fill equal quality of care new. And then the area should be equals to what? N. Now remember, N is representing the frequency or the number of observation for each of the levels, right? And then we are going to use what is called geom underscore tree map. And that is what is actually going to help us generate that tree map. Plus, then we are going to give it some names, okay? So we have title. Within the labs, we are going to give the title of our plot, which is tree plot of what quality of care. Okay, so we can go ahead and then run that line of the code. So you can see. So this is very similar. So from this pie chart, you know that people with very good quality of care have the highest, followed by excellent quality of care, right? Now, in the same way, you can actually see from the trip map, which is also showing the very good as the highest, followed by the what? Excellent, and then we have good, fair, and then what? Poor. So only few people tend to have poor quality of care in the HINS data. Okay, now alternatively, we can also have a different plot of the same tree plot, but in this case, we are actually going to introduce what is called geom_tree_plot_text, which we are actually going to have color equal white, okay? And then place the color in the center. So we are just adding in additional argument that allow us to be able to have a different display of the tree plot, okay? So everything else remain the same. You have the data within the ggplot. You have your aesthetic, which is the field called the quality of care new. Now this time you have the area, which is equals to n. You have the label, which is the quality of care new, okay? And then you can actually, and all come within the what? The aesthetic. Now, you have this line is the one giving you the tree map. Now there's an additional information that go to beautify the tree map, and then now you have the labels of the tree map, okay? And then you actually don't want any legend. So now let us run this line of the code. Okay, so this is what we have. So over here, remember we said the tune, which is legend position, is none. We didn't want it because we actually want to write everything within the plot itself. And that's how also you can generate a different plot. Now, next, again, on a univariate distribution, univariate visualization, we can also generate a line plot of a particular variable, just a single variable, but we are going to create, before you create a line plot, often you have to have two variables to create a line plot. But if you want to create a line plot of a single variable, just to understand how its distributions look like, you can actually index it, okay? The sequence or the order of the rows, you can actually plot it against the index of that variable. So we are going to create a line plot for BMI, but then we are going to create it along with the index of BMI, okay? So again, using ggplot, we have our data. Now our x-axis is going to be the index value in which we want to create, which is going to be from 1 to the number of rows of the data, okay? And then we have our y-axis, which is the BMI we actually want to plot against its index. So now geo_line allow us to be able to give the color of the line we actually want to create. And then we have gg title, which is giving us the title of the plot, which is line plot of BMI. And then we have x lab, which is also going to give us the index, which the label of x-axis, which we are giving it as what? Index. And the label of y-axis, which we are going to give it as what? BMI level, okay? So now let's highlight everything and then let's run it. So there's what, so I mean, this actually, it's so hard to read this line plot against the index because there's a huge data. I think we have over 2,000 observations. If you look at the, I think we can look at the dimension of the HINS data. Yeah, so we have 2,738 observations. So, I mean, you are not going to actually be able to read it very clearly, okay? And I mean, so, but then for a more clearer version of the line plot, let's use this data, which is the empty cast data, okay? So before there's an inbuilt data in R, so we can just use the data function of what empty cast, okay, just to call that particular data. And now, just like we draw this line plot, we are actually going to be able to replace. So we are going to, within the ggplot function, we have our data, which is the empty cards. Again, the aesthetic, which is going to be X versus Y, but the X is going to be the index of the number of rows for the empty cards, which is from 1 to the total number of rows, okay? And then we have our Y is going to be the MPG, which is the mass per gallon. Okay, so we are going to draw the mass per gallon against its what? Index. And then again, the GG title is going to be the line plot of what? MPG. The YX label, which is the how we label our X axis, is going to be the index of the MPG. And then the Y label is going to be miles per gallon, which is the MPG. So now we can highlight everything and then we can actually run it. And you can see this actually gives us a better outlook of the how the relationship between the MPG and then its what index, how it actually looks like when we plot the MPG over its own index. Okay, so there's the univariate visualization, different univariate visualization you can actually get from the using the ggplot2 package. Okay, so I will see you for a bivariate visualization in our next lecture.